Jeez. Sorry, it's been a while. um, hey, everybody. So, there were a couple weeks after the last session where I just felt absolutely lethargic and unmotivated. I think, not to get too morbid here or personal here, but the situation in terms of the pandemic really started getting to me, I think, and I really started realizing the full implications of well, I don't want to get into it. It's just like there's a lot of death involved, and I don't. That was really bothering me, and then a couple things like that, and then I stupidly did not remember the second time that I was just like, I'm not up to it this week. That I was asked coming up to work some weekends in order to help us get to a particular milestone at work. And so that's what happened last weekend. So I worked, God. Well, I also worked yesterday, but it was only like a couple of hours, fortunately. So I'm not necessarily happy about that, but I am happy that it wasn't like Saturday and Sunday again. So yeah. So basically, I worked Monday through Saturday. That'd be 8, 9, 10, 11, 12, 13. Like 13 days in a row. I was just working, which ended yesterday. So yeah, that was not the greatest. So now that that's done, Christ, and I'm getting re-tormented by roaches, and I'm losing my sanity a little bit. Um, I decided to start working on something different because part of me wanted to, but part of me also wanted to, learn something new and hopefully start building this up towards its own project. As you can see, I'm in the You Stole My Future project, which I showed off, I think, pretty early on in the streams. I think at some point last summer I showed off the player character controller that would switch between first and third person. Um, so yeah, for the moment, I'm just using this. And I actually broke out Blender and started getting used to oh God, shaking off the dust of my 3D modeling and animating skills, which are not terribly great, as you can see, but they are. I can get something modeled, exported, rigged, and animated. Um, like it'll work, it just won't be good, you know. So yeah, I had this bizarre idea for my horror game where um, I sort of wanted this weird like rats in the walls sort of idea, where rats in the walls. If I recall, I can't remember if this is Lovecraft or Poe, and I think that's a particularly embarrassing mix-up on my part. But it was basically a short horror story about a guy being driven insane by he had to go live in or he had to go stay in a house to inherit it, I believe, overnight. Classic thing. And then there's just all these skittering noises in the walls, and it's basically rats, but he can't seem to find any, and it just basically drives him mad. And I felt that way about the roach problem in my apartment, where it's just like it's very difficult to see them or find traces of them, but that they're still sort of a problem. And so hyper fixating on like every little black spot of like crud on my kitchen floor or something like that. And so I had this weird idea of just like the climax of Rat in the Walls, but it was like me swinging an axe or something into my walls and imagining like roaches just pouring out like water or something. And I thought, Jesus, that's creepy and terrifying. I should make a game about that, or I should like try to find a way to make that interactive. And then I realized something that was interesting to me is the idea of a swinging an axe in a game, but not just swinging an axe the way in God of War, where you like press square and like Kratos swings an axe, and it's one of a few animations. Like I really wanted the player to be able to like aim this thing, and so that made me realize that if I were to allow the player to adjust the angle of like an axe that they would swing, I would need to start getting into procedural animation, which is basically doing animation, but calculating all of it through code. So let's start talking about what procedural animation is. Or rather, how animation works in general. If you're not aware, there are multiple steps to getting a 3D model, animated and moving in a game engine. Certainly, I think most everyone knows kind of what modeling looks like in terms of, making 3D models. And we basically have an example of that here. Not a very good one. But I literally, had this, orthographic view, and I previously had like human proportion photos and drawings, like sort of transparently on this grid line as a 3D object. So I just literally like basically traced this. So the only reason that this looks, like an actual human, and it kind of looks plausible as an asset, is because, I was basically working off of someone else's proportions, reference drawing. And that's also kind of why he has this pose. It's not like your typical T pose or anything like that, and that's just because that's how the man in the drawing was posed. I literally copied that because I'm not terribly good at proportions otherwise. I'm not good at modeling otherwise, rather, but especially proportions, because those are tricky. But I thought, okay, this looks okay. And then The next part of it is doing something called rigging. If you're not familiar, over in the project view here in Blender, we have this humanoid skeleton. It's also, posing itself now. And if I make this a wireframe, okay, you see all these weird little points and triangles. Yeah, so the thing is that depending on who you ask, this is, and there's like different nomenclature. This is a rig, or in the case of Blender, it likes to call this a skeleton, and then the rig is something that you basically add on top of this to make it way easier to animate instead of like manually rotating and positioning all of these what are called bones, actually. So basically it is quite literally mimicking, the idea of the human skeleton, as well as, the way that the nerves and the muscles move together, because, that's our sort of reference point for animation. This is just about rotating. Oh, it actually isn't staying together. Whoops. Interesting. Oh no, because interesting. No, that didn't do anything. All right, so basically, yeah, the way this is set up is that there are bones here. Like if we open up the human skeleton here, humanoid skeleton, forgive me. The root is the spine, and that is the bone we have currently selected, I believe. It's the base of the spine. And then you have, yes, the next bone in the spine, and then all the other bones that are connected to that, such as the pelvis bones and the thigh bones. And then down there, you go down the chain of, the spine bones, and then eventually you get to the shoulders here. And then for the legs, you get to the shins. And so basically the idea is that, as I found out while researching inverse kinematics, which we'll be getting into in a bit. Oh, God. Interesting. There's something called forward kinematics, basically. Actually, let me... If I do pose mode. Yeah, that's much better. Okay. There's something called forward kinematics, which basically says, bones that are further down the chain, which is to say, in this case, the wrist and the forearm compared to, the shoulder bone here, or the upper arm bone, rather. They're going to be affected by the transformations of the bone further up the chain. So, I rotate the shoulder, the whole arm rotates, but it keeps its same position relative to this parent bone, and then you move that around, rotate it a little bit, all that. And basically that's, how you get something animated. You have to create a rig, and fortunately Blender actually has something called Rigify. Yeah, you see that keyword here? It's something called Rigify, which basically auto-generates, humanoid rigs, which is very fortunate, very easy. And then you kind of bind it to the mesh, and then there are, if I recall, edit mode, pose, no, not pose mode. I'm trying to recall how to do this. Object mode, and then vertex weight paint. There we go. So basically, if you sort of bind the skeleton to your mesh, it automatically adds what are called weights to each vertex in the mesh. So, most of the time when it does it automatically, it does a pretty good job, because basically when we're messing with this bone, basically, or any bone, it's only supposed to sort of affect and transform the vertices that are closest to it. And it does a pretty good job automatically assigning that, basically. But there are some times where you need to adjust this, like say for whatever stupid reason I want to have the chest affected by me rotating the thigh bone. Then you would just kind of... This is not going very fast. I'm trying to remember the... Oh, yes, weight, strength. Yeah, so if I did... Yeah, that's more dramatic. So if I would just add this to the weights, and then you would start to see this be affected by movement and rotation of the thigh bone. Obviously, we don't want that, actually. So, to just give you a sense of what's going on. And then you go into animation. And then with this, and this view took me so long to actually figure out what the hell to do. But eventually I got it. Made a stupid animation for Hamish. Yeah. So that was actually my first one, because it was actually pretty simple. But yeah, then you go into your timeline, and basically what you do is that at different periods of time along here, you tell the bones in the model to actually have different transformations, and so you move them and rotate them, and you do all that. So if I go 40, we can actually take a look at that. And so because of that, that's how you get animation. It's basically just saving data regarding the position and rotation and scale sometimes, but I'm not really using that in these animations. It's basically just saving those positions for particular bones at particular frames, and then the computer basically just sort of averages the position between keyframes. And that's sort of how animation data is stored. So the thing is that, these aren't... how to describe it? It's like the computer is actually getting only like snapshots of what this thing is supposed to do. And then it is basically, whenever playing, sort of filling in the gaps here and calculating that on the fly between all of these. And so basically, the more precise and the more data you give it, the more accurate it's going to be. But of course, that gets into, say, more complicated animations, and that also like generates more data that the computer has to process. You know. So this is kind of where we get into so nice little oh right, because this is 60 frames, not 40. This is one of the things I don't like about Blender. It can't just tell you, or you can't just like have the end frame for playback just snap to the last frame in the animation. Or if it can, I don't know how it does it. So yeah, he's just kind of rocking a little on his feet. There's a bit of breathing in there as well. You can kind of tell the spine straightens up and then relaxes. I'm not a terribly great animator, but I'm pretty happy with that. It actually works. And so, basically, once you understand that, what you're really doing is you are merely taking certain points within this mesh, and you are merely applying rotation and position to them, then you can start to say to yourself, what happens if I manually set this? What happens if I like tell a piece of code to actually move these around? And that's how you get procedural animation through coding. And basically, it's just you calculating how to get this to do something at runtime that you can't really animate prior, or at least that is a very good use for procedural animation. If I pull this article up, this is something called inverse kinematics. As I referenced earlier, I've been following this article. Forward kinematics, as I mentioned, is when, it goes down the chain of bones, and then, when you move your upper arm, obviously, like, your lower arm comes with it. Like that. But the thing is that if you say wanted to move your hand to a particular spot, like you're grabbing something out of your cupboard, your hand would come up, and you don't really think of the way to reposition your arm as you do it. And so the thing is that I don't have this working in Blender, basically, even though it has inverse kinematics stuff set up. But basically the idea is that you would be able to move your hand to like this point, let's say, out in front of you, and then you would just know how to position your arm in a way to allow your hand to get to this point, basically. And so in the case of wanting to pose an axe and have the player be able to aim at the particular angle, hang on. details. Did I... Oh my god. Oh, unless live replay when stream ends. That's good. Okay. I did a stupid thing again. Somebody did not change it from unlisted to public. Again. I've been going 25 minutes. 26 minutes. Before I fucking realize this. Jesus Christ. Why isn't anyone tuning in? Oh boy, I'm a dumbass. And to confirm, yes, it's now public. Oh my god. I'm an idiot. Did they tell me this on Discord? I'll have to check. All right. Do I start over with this? I don't know. Will this stuff be... Will people be able to see that on playback? I think so. Anyways. Well, if anyone's lost and makes a comment, I can just re-explain. So yeah, I wanted to do inverse kinematics because that is an example of procedural animation. And I wanted to start doing that so I could use use that for a particular axe swinging system where the player can actually aim it. So the thing is that, as you can tell, this is, if I look, yeah. If we look at this guy's example image, and this is his coding example, there is, uneven ground here, basically, and, with the sort of default animation pose that's created for this guy standing still, there is, you can see his foot is clipping through the ground because the collision is actually somewhere, I would imagine for the origin, it's somewhere like right between his feet, basically at the average position there between the two. And so, because of that, vertically, the foot here lines up with that point, that origin, even though that makes it clip into the ground. And that doesn't look good. So, inverse kinematics is a way to basically move the leg at runtime dependent on the ground and its slope and position in order to actually make it look like his foot is resting on the ground, which is really nice. So basically, not to get into too dry math stuff, but this is kind of complicated because this involves 3D math regarding position and rotation. Position is not too difficult. Rotation, however, is a nightmare. So, basically, and like you get into this stuff, this is just like hieroglyphics to me, honestly. But I wanted to push forward and actually learn how to do this. So, I made a little demo here, and here's some of my code up on the second monitor in the little corner. This is basically where I'm at right now, because my first test is I basically just wanted to rotate the arm, and then once I got that down, I wanted to actually have the arm be able to move the hand or the wrist bone to wherever I have the mouse cursor, provided it's within range. And so it's not quite working properly right now, as you'll see in a moment. Is it actually running? Oh, right. Because I commented these out. Okay, so now if we play. And here we are. Okay. So the arm is moving, as you can tell, but it's not. Like if I move my mouse cursor over here in range of the arm, it doesn't actually do anything. It seems to get locked into this particular pose for whatever reason. Pardon me. But if I move it like down here, weirdly enough, it actually seems to be doing okay. It is actually kind of moving in the way that I would expect it to. However, it is there's a particular issue with it seems like it is only moving basically along like this line, basically. If you notice, like the hand can only move in a straight line that's slightly downward. And I don't know why that is. And then for whatever reason, just most of the time it snaps to that particular position. And I'm not sure why. So basically, this is a really complicated case. Or it's really complicated math, rather, but so because I want to get a good snapshot of this, kind of. Actually, I can just freeze this up, basically. So some of the math behind this is really interesting. I'm sure most of you, if not all of you, at some point learned about both the Pythagorean theorem in school, as well as trigonometry, that favorite of in math. Calculating a bunch of shit with in regards to triangles. So, anyone here? Yep. So, I have my red pen here. So basically, in theory, the way this is supposed to work, and let's actually use the black pen for the cursor. Let's say my mouse cursor, which does not look terribly good. Let's say my mouse cursor is in this position. I basically want my hand here to move to that position. So the thing is that you have to figure out the rotation of the upper arm bone first. and then you have to figure out the rotation of the lower arm bone as well. And so the difficult thing is that, there's only some particular combination of rotations that'll actually accurately position the arm to get there. So if we switch over to the red pen here, the thing is that what you can think of in this case is that the origin of the shoulder bone, the point that it pivots around, is a particular coordinate. And where you want to move your hand to, in this case, is another particular coordinate. And so you can get the distance of this. Let's call this, this will be side C. That kind of looks like a lesser than symbol, but And so the thing is that in theory, you will have your lower arm in some kind of position over here, and then you will have your upper arm in some kind of position here. And this will be your elbow, basically. And this will be where the elbow is positioned. The thing is, we don't actually know the angles here. We don't know any of them. And the thing is that with the Pythagorean theorem, bam. The thing is that with the Pythagorean theorem, as well as, regular trigonometry, or at least the stuff I learned in high school, that's all dependent on having a triangle with a right angle. And the thing is that because we can arbitrarily position the mouse cursor wherever, we don't have a guarantee that that's going to be a right triangle. And by the way, let's label this A and B, basically. But we do have some pieces of information. First off, because we know the coordinates of these two places, you can calculate the distance between them. And the thing is also that with the upper arm and the lower arm, we also know what their lengths are, because they're not going to change. And so, if you basically get the difference in position between the shoulder and the elbow and the wrist, then you know the lengths of A and B as well. So we know how long all of these triangles are, or the sides of the triangle are. And because of that, there are only certain that will determine their angle, basically. But I was just like, I don't know the math to do that. I don't know how to get that. And then I was actually following along with this article, and it has a simplified 2D case, and it's basically talking about the same stuff. But it says we can just solve the angle A using the law of cosines. I'm like, a law of cosines? That sounds extremely complicated, and what the fuck? I gotta look this up. Then it was law of cosines. And it's just this formula, basically. And as people, as the article points out, this is basically just a fancier version of the Pythagorean theorem. C squared equals A squared plus B squared. That works with right triangles. But basically it adds a cosine factor to this. And so it's A squared plus B squared minus 2 times the length of those sides times the cosine of the angle. And so therefore you can rearrange that formula the angles of a triangle of one of those three sides, and you get this complicated looking thing. It's really not that bad. So I actually figured that out. But clearly I'm missing a step. So actually let me back up. I'll show you guys the first test I did, basically. Actually, I deleted that code, I believe. But basically, to just get things hooked up and working, I added some code in here that was merely pressing the up and down arrow keys, and it would like rotate this arm like 5 degrees or 3 degrees each time, I believe. Yeah, angle increment value 3. So just move it, kind of like, the hand of a clock if you pressed up or down, and just to actually get the code to understand how I'm able to actually access the player's skeleton with all of these, pelvis bones. These are actually just child objects in the Unity object, basically, if you recall. Replicating the actual layout of the skeleton in Blender. So once I got that set up and I knew, like, okay, I can access this, basically, I can actually access the shoulder bones in particular, or the upper arm bone, rather. Oh yeah, and you can see like the origin points for all of these. So, now that I knew how to get that and rotate that, my first test was basically just getting it to follow the mouse cursor and doing, oh right, because I renamed this. Upper right arm bone. Oh no, that's not what I wanted. The init rotation. And then this is now shoulder to wrist line, because naming that variable point2 point, which is the point you're pointing to in this case, was not a terribly good name. It was not terribly descriptive. So if I run this code in particular, this is merely just going to get the angle from the shoulder point to my mouse cursor. Hey guys. And it's merely just rotating the shoulder, or the upper arm, more specifically, in order to create a straight line and actually point to my mouse cursor, which is pretty neat. So I was really happy once I got that working. And then, I went into this more complicated law of cosines thing. And so I've been playing around with this thing. And the problem is basically, well, first off, if I kind of find the actual shoulder again, the upper arm. The initial rotation here is kind of bizarre. What if I set all this to 0? Yeah, it's kind of T-posing. That must be why they do T-posing. So they can have all the rotations set to 0 by default. Just makes things easier. I, of course, again, did not have him T-pose because I'm a dumbass. And so now I just have to live with this complication, basically. What is that, 57? That was from a couple? No, that was from the last thing. Well, it happens at both points, weirdly. Just compare approximately square magnitude. But there's no square magnitude in these lines. I'm not calling it there. So basically, with the article here, this is sort of the problem. First, you need to figure out this line, which is the rotation point from the body. In this case, the pelvis. In our case, the shoulder. To where you want the end of the appendage to end up, basically. Sorry, I'm kind of tired. And basically you need to figure out this has a triangle, and then you need to figure out the angles internal to the triangle. And we've done all that. We can solve the angle A using the law of cosines. Got that done. Then we can calculate the vector pk prime, which is not a NES smash move. Sorry. So we got pelvis to knee, PK, and then there's K prime when the knee is moved. I need to figure out this position, basically, and then figure out where my guy's elbow was last frame. And then, between these two lines, I have to figure out the precise rotation to apply to get there. And that's the step I'm missing at this point. And that is what I'm trying to figure out at the moment, basically. So there's a more simplified version that Unity has built in for transforms, which is called transform.rotateAround. But the thing is that I did not set up any of these to create a transform, and just saying transform here, I mean, that doesn't work. and I can't declare a new transform for some reason because Unity won't let me. So it's kind of difficult. So now I'm trying to figure out, as this comment says, I'm trying to figure out the vector 3, which is a three-dimensional coordinate with elbow target point. That's what I'm calling it. I need to rotate the shoulder to wrist line by shoulder Z rotation degrees. And get the point on that line at the distance of upper arm length. And that's the difficulty I'm having. So if I puzzle this out with trig, and let's start fresh here, by the way. Oh, it's still, interesting. Sort of like that. Stop. The difficulty is I'm trying to, and I might be overthinking this. I got my mouse cursor here, and we have, you know, the lower arm, the elbow. This is not going to look remotely plausible as a triangle, but sure, or as arm lengths, but sure. So basically the thing I need to do is I have this angle. Actually, can I undo? No, you can't. You can't undo in a snipping tool, regrettably. Basically, I know this angle. And I guess now that I messed around with the rotation of this, and I manually set it to 0, I know that the rotation of 0 in this case is horizontal. So that actually helps. What I really need in this case is, because if this were, say, 37 degrees, let's throw that out there as a number. If this were 37 degrees, if I set the rotation to 37, it's not accounting for, the difference in angle between this line and the horizontal, which would be 0 rotation. So I guess what I need to do here, actually, is all I need to do is figure out this angle and basically add that to this. And then that'll give me a more accurate result. Oh, I didn't save this, that's why. I didn't save the comments here, so that's why I kept rotating. Regardless. Hey, Rosso! Finally got a comment. So, while I am trying to figure this out, I think, so what we do have in this particular case is this is going to be along the x coordinate. I cannot draw for shit. We do have the x and y coordinates in difference between these two things. So basically, I'm just getting the difference in x and the difference in y. And that forms another triangle. And similarly, well, A, because of this, this is a right triangle. So we can just use regular trig instead of the law of cosines and get all fancy with it. So basically, I just need to figure out this angle. And then add that. And then we will have the upper arm rotation. And then we'll have the elbow position. So that's interesting. Why am I getting a curl error? What the hell is that? So we can at least figure out the upper arm rotation properly. And then from there, getting the lower arm rotation shouldn't be difficult, because that's, again, just a, you know, if it's rotated 0 degrees relative to the upper arm, then it'll just be straight out, right? Yeah, and so basically at that point we wouldn't need basically a yeah. You know what I mean? We wouldn't need to, you know, recalculate like a second triangle and all that. At least I don't think we would. I hope we don't. The upper arm right, the forearm. What is going on here? Yeah, to be fair, I mean, it is kind of up there a little bit. If we basically put that to 0, 0, 0, then yes, at 0 rotation, the lower arm is straight out from the upper arm, so that's good. Okay, so I think I know how to fix this. Shoulder Z rotation. So what's the current objective? It's some procedural animation. Did I show you my derpy looking demo? I'm trying to start with inverse kinematics to get the arm to be positioned in a particular way. And you can see it moves and it kind of works in very particular situations. But what I really want is to move the mouse around here so it actually follows the cursor accurately. And quite clearly that is not happening. So I'm trying to fix that. So the thing is, I don't really need a vector 3 for the elbow position, basically, to figure out. I don't actually need that. What I need to do in this particular case is I need to get the difference in x and the difference in y between the shoulder position and the target position, the shoulder to wrist line. So let's call this arm delta, because why not? It's basically, well, I'm not sure that would be a float. Let's go with vector 2, because we're doing, we're calculating the x and the y, so we only need 2 coordinates, basically. So that is going to be vector 2 ought to be, oh, I always forget the order of this to make sure it's going in the right direction. I gotta do this every time. So if this were 0 and the point was at 1, 0 minus 1 would be negative 1, which added to that would be pointed that way. So it's 1 minus 0 will be 1. And negative 1 minus 0 will be, or negative 1 minus 0 would be negative 1. So yes, it's shoulder to wrist line dot x minus upper right arm bone dot position dot x, and then the same with the y. Position dot y. So that gets us the 2 sides of this blue triangle. And because this is a right angle, or a right triangle, it should be pretty easy to get the what would I call that? The origin delta angle, sure. So basically that is just going to be the arc tangent, right, of the opposite over adjacent. All right, because I have the a cosine. Yeah, and this was the a tan 2, right? Math f dot a tan turns the angle in radians whose tan is y over x. Times radians to math dot f dot radians 2 degrees, because I am not smart enough to use radians. And that'll be arm delta dot y over arm delta dot x. Oh no, you just actually pass both of them in. You don't actually divide it or give it a float. So actually, just to test to see if this is working. To hide this log spam, I think. Well, no, I could just filter out warnings. So you print. I do delta angle is equal to, and then origin delta angle. And then we should be able to test this. So you just need to compute what angle each joint should be in to attempt to follow the cursor. Yeah, kind of. I went over some of the law of cosine stuff earlier. And the thing is, I kind of did calculate that, but I also need to calculate basically the offset for those. I can go over that again in a bit if you want. So if I'm not doing log spam, it's about 1.3, it's about -16, about 17, is about 45, 46. Yep, looks like that's correct. No, okay. Okay, so that looks good. I think this will also be handy as well, because if this basically goes over 90, then I can just say don't pose the arm or something like that, or I can do some special case. So in essence, at least for the Z rotation, because this is a very basic example, I'm doing this relative to like the world axes. So this is only going to work from this particular angle. I'm rotating everything around these lines, because this guy is very particularly faced in this direction. So because of this, the rotation of the upper arm, in this case, should just be the origin delta angle plus the shoulder Z rotation. If I'm calling this correctly. But I think the thing is that when it's down like this is a negative angle, if I recall from the output, and this is a positive angle above this line. But I think the rotation of this is actually going the other way, frustratingly enough. Yeah, the upper arm is... Oh, no it isn't. That's actually negative. Oh, fuck it. Perfect. Hopefully the shoulder Z rotation will help me in this regard. Will the shoulder Z rotation generate a negative angle? I don't think it will. Fuck it. We gotta test it and see anyways, so. Origin delta angle, yes, please. And then for the lower right arm bone, I have zero idea what to do with that right now. I think it would just need to be at elbow Z rotation. We're getting at least more varied movement here, I think. But this is basically off like 90 degrees. This is not great. If there's a way for me to like hit pause while it's like mid that way. It resulted in something different. So I don't think I need this to be printing, but what I do need is shoulder Z rotation so I can actually tell what's going on. Yeah, it's positive. It's like 48.8. Oh boy, the way that thing can like pass through itself as an arm, that's not a good sign. So this is difficult because basically if it's negative here, yeah, basically if the rotation is going to be going into the negative, then the shoulder Z rotation will need to be multiplied by -1 to make it negative as well to match. But if it's positive, then it'll work fine. Well, actually, let me test that. If I pose it up here, no, it's still not doing anything. Gosh. Yeah, it also basically feels like it's about 180 degrees off from where I want it to be, basically, in terms of the line from the cursor to the shoulder. So maybe I need to redo those or reverse that somehow. I don't know. But okay, I don't think that'll be too difficult. If origin delta angle is less than 0, then the upper rotation here needs to actually subtract that instead. Else, this will just be positive. So hopefully that'll resolve this somewhat. Should look a little more in line with what we want. Oh, interesting. Well, what is going on here? How about over here? Does this do anything? it's saying it's like 34 degrees at this point. That shouldn't be true. Here it's saying 19. All right. Well, now that's a different thing I'm thinking of. If I do, let's do a draw ray. Vector 3 dot start, which would be upper right arm bone dot position. Start plus direction in world coordinates. So that should be our shoulder to wrist line. Color float. Okay. And it's not drawing it. Why? Well, we just do color dot, I don't know, red, and then have the duration be like 1/10 of a second. That should be fine. I think that's the issue. Oh, must we? Can I pop this out, basically? Okay, yeah, so I think it's gone, yeah, so I think in terms of calculating the line, I think I think it's just pointed in the opposite direction, 180 degrees, and that would be a big error to start out with. So well, that shouldn't go that direction. I wouldn't think so. Where would I have the opportunity to mess that up? Screen to world point. Basically, if I multiplied this whole thing by -1, it would just make the opposite. It would point exactly 180 degrees in the other direction, right? So, I don't know, it's a stupid hack, but let's try it. So then, times equals -1. Can I do that? Yeah, apparently. All right. I would like to move this. Okay, not quite. But we are getting closer, I think. Because now we are actually sort of in this quadrant, and the arm is kind of pointing down. Yeah, maybe not. But if you see on the main screen here, like my cursor is down towards his knee, but it's still pointing in a completely different direction. God. So again, well, being multiplied by a negative here. I think it's trying to target that, although the elbow position is still not quite there. But the upper arm angle looks right. It's just the rotation of the lower one, and also I'm just pointing in a completely different direction than I should be. I think we're getting closer. So no, I don't think that solved it. And let's draw this before we do our rotation, because it shouldn't move anything, but I just want to be sure, you know. No, it's still completely off. What the hell? Well, I don't know. Is this a problem with the distance? Like, is it pointing... Is it pointing like way out here instead of No, that wouldn't make sense. Okay, but it does think that it's pointing like in that direction, you know? But now it's... Wait a minute. What? Okay. So the line... Oh, dear God. Gee, that could be it. No PDF, Sam. Okay. So I'm moving my cursor around. I don't know if you can see in the smaller view on the side. But it is largely in line with the direction I'm moving in. But I was wondering, where the hell is the origin? So if I trace this line back and I look at my cursor, it seems to be the origin of the whole humanoid mesh, not the shoulder. I think that's probably a huge part of it. So I'm getting this relative. So I'm getting the angle relative somehow to, like, between his feet. What the hell? Okay. So I'm, like, using the position of this guy somehow. Let's upper right arm bone dot position, which is the get bone transform. Is the get bone transform returning the local transformation, and I'm using that as global? Let's test that out. Position. Lower. That'll be lower. Okay. So let's figure that out. Come on. This will clear on play, so. Pause, go all the way back up here. Is 0.2, 1.6, negative 0.1. Can I create something during runtime? I think so. So if I were to, and this returns 0.2, 1.2, negative 0.1. So if I put this at 0.2, 1.6, negative 0.1. No, that's also, this is gargantuan. No, that's exactly where it should be. Oh, wait, hang on. Oh, jeez. I think I'm dumb. This is just a big oversight. I think I got the... Oh, boy. I think I got the... I got the screen to world point here, but I completely forgot to get the difference between the screen to world point and the shoulder. Because relative from the origin, actually, this is just the origin of the world. It's not that it's the mesh's origin, although that also happens to be true. It's just getting the difference from 0. Jesus Christ. Snapping out of place like that is unstable Euler angles. Probably. That's part 2 of what we gotta figure out. Oh my god. So I didn't actually... I forgot to fucking get the difference. Oh my... Minus equals... yeah, the upper right arm bone dot position. Jesus Christ. And oh my god, at least in certain angles, it's way closer to working. Doesn't seem to actually... Well, it's a lot closer to what we want. Let me actually pay attention to the ray. Yeah, it is exactly as we would expect, going from the shoulder to the mouse cursor. So this is interesting. It's only really going halfway, basically, towards... The elbow is really only going halfway towards where we want it, in terms of an angle. Or at least that's true in, like, this case. It's also occurring to me maybe that this, if the origin delta is positive, then it should be added, and if it's negative, it should be subtracted, is kind of naive. Because we have the cursor up here, we would want our guy basically to pose his arm like that, and that would still be a negative rotation. So I think it is just in all cases. That we should just subtract it. Yeah, because if it's like up here, that would be a positive rotation, and it would subtract the angle anyways, but it would still be in the positive in this sort of case. Okay. Okay. I don't think I need this. I'll comment that for the time being. Thinking here. If based off of my based off of my epiphany here, if my calculation down here is wrong. Well, first off, let's do parentheticals here. It shouldn't matter, but it would make me feel a lot safer. Let me go back to that article. Oh, Rosso, dude. By the way, I went over this prior. The law of cosines is what's really helping me with this math. This is basically a way to get sides or angles in a triangle with any set of angles, not just right angles. So this is sort of the math I'm using. This is a more complicated Pythagorean theorem, basically. It just adds a certain number of, a certain term here. And then in the case of trying to get the missing angles, you can use it to solve for the angles of a triangle if you know all three sides. In this case. Which I found very handy. Right, I wanted to go back to this. Hence, this angle can be calculated with the dot product between the vector p and vector pk. The angle at the knee joint can be solved either by law of cosines or the dot product. Oh. Well, first off, we didn't use dot product in this case, which is another complicated math thing. So what it's basically saying is that it wants us to calculate this angle first, A here, then rotate the knee to get it into this position. Then it wants to calculate this angle as the last step. So I don't think in this case it'll change anything, but I just want to check. Yeah, not really. Making scratch his back. Okay, again, so in this case, you would think that, you would think that the elbow would rotate itself basically the other way around for this angle. So I think this basically means it's only really able to add a it's only spitting out a positive angle, I think. But it's not rotating like it's positive, I don't think. Upper arm, Z is negative. Forearm, Z is negative. And let's... Actually, no, it's still getting adjusted as a negative angle. So why is that? So yeah, the changing of operations here, order of operations here didn't do anything. Which is good. Pardon me. Well, this isn't declared yet, so... elbow 0. Yeah, it's like 133 or something. I forget how to pause in Unity. It's like Alt-P. No. Well, if I actually look at forearm here for the rotation... Okay, so it's at 117, and it's negative 132. So it's like being made negative and then subtracting 15 degrees, at least in this case. Is that true here? It's 156 and it's negative 119, so no, probably not. Is it also setting this in terms of world rotation, or is it local rotation? Because I feel that might be part of it. Local rotation. Okay, that might be it. Yeah, because the shoulder bone here, I think, is... No. No, that's a lot of rotation. Okay. Oh. Elbow rotation is about 95 degrees. Oh, wait. Hang on. Hang on. I'm dumb. Oh, it's not that simple. It is rotating it based off of the shoulder rotation, or the upper arm rotation. Why do I keep saying shoulder? Upper right arm bone dot rotation. Arm bone dot rotation dot z plus the elbow rotation. And that basically gets us back to this point. 138 degrees. Well, it's still not doing that. Oh, I'm looking at the shoulder. 125, 130, 55, negative 117. Like, what in the world is happening? If I try this as local rotation, will that work? No. Like 125 degrees is about, or needs to be. Oh, wait a minute. If it's spitting out an angle of 125 degrees internally, oh, I think I know what's going on. Ew, that's not good. Let me explain. I think I know what's going on. Let's get some a little wider. Okay, so this is pretty simple. This, of course, is completely disproportionate to what a human arm is like, but bear with me. I see what's going on. So, what we do when we calculate this internal angle here is that we are basically saying that it's this angle from 0, basically. Or that the upper arm angle here is 0, and we're rotating away from it. What is actually needed is, because the lower arm is actually pointing this way relative to the upper arm, if it were rotated 0 degrees, what we actually need is this other angle on the other side, which is, basically 180 minus our angle. So, that's what's going on. Okay. 180 minus elbow Z rotation. And hopefully that'll resolve this. Basically pointing the exact opposite. So let's do negative 180 plus the angle. I don't know why it's doing everything backwards. But hey! Well, it was. Kind of. There's a very particular area where this is true. Okay. So we're a lot closer now. I think in this case, like out here, we're getting more towards yeah, it just doesn't know how to deal with this. Maybe this is the case where we need to flip it if it's positive. So we're kind of pointing it in the right direction. I think in this case, the length of this line from the cursor to the shoulder is now longer than the upper arm length plus the lower arm length combined, I think, and that's why we're getting wider and wider angles. That doesn't feel right. But hey, we're actually a little closer than we were. This is also interesting. It looks like the screen space point is a little closer than the body generally. Or maybe it's just rotating that way. Yeah, it's just rotating that way. Hey, that's looking slightly better. Okay, so let's bring this back. If original delta angle is greater than 0, and that'll be 180 minus elbow rotation, else we'll do the negative here. So hopefully it'll be a little more well behaved in the positive direction. No, not really. Is the upper arm also dealing with that 180 degree thing that I didn't quite get? That might also explain some of the derpiness. Yeah, let me think through this again. Let's go with the black. Oh, it's a much better cursor. And that was a much worse line. So I can just test this, actually. Sorry, I got hung up on No, not shoulder Z rot. That should be rotation dot Euler angles dot Z specifically. $107, that's, oh no, shoulder zero, it's 240. But it's saying that the rotation negative 29? 254. In this case, it's being subtracted. So it's like adding up to 270 here, or negative 270. That's odd. Okay, so this, just set this to 0. Well, we got the offset plus the angle here. That shouldn't be the problem. Maybe we do need this again. Right, so I was saying earlier, I was listening to a Horse with No Name for some reason, and that band America, they're actually named America. They that whole album, the first album that they did with Horse with No Name on it's actually very good. I was very surprised. So, okay, I think hopefully that'll point us in the right direction. No pun intended. In terms of being able to, no, not really. Yeah, maybe. Maybe it should be local rotation. No. 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 That ain't it. Maybe let's try this. Oh, this is interesting. Okay. It's basically now pointing in the opposite direction of where I want. So maybe now I have to reverse this because I didn't think it would be the other way around. No, I think it's still local rotation. Maybe I need a better case here. It's still not working. So this is a case where it's negative 180 plus the elbow rotation. The mouse cursor is above the shoulder, so this shouldn't be happening. Pardon me. So yeah, when I explicitly tell it that this is the case where it's positive, basically, doesn't seem to actually want to position everything upwards. So actually, I think in this case, if we basically had a mirror image of the arm across the X axis, then I do think this would be in the right position. It's just it's setting these things to be negative for some reason. And I don't know why. Actually, I want to test something. I'm just going to explicitly set this to 0 for the upper right arm bone to see where the hell it actually ends up. That's 0? Ah. No wonder this shit's off. What if I do local rotation 0? Okay, yeah. Okay. I see. Yeah, basically we're halfway there, I think, in terms of the angle. And now that it's pointing downwards, it's able to like switch axes or switch directions. Okay, so I'm applying transforms to the shoulder in the world space rotation and not the local rotation, but that still that still has us come up with very bizarre. Hey, where's my other window? Where's my game window? Oh, it appeared there weirdly. So clearly there's a calculation here that's off. Because somewhere I'm still using the world rotation. Upper right arm bone in it rotation is that was world rotation, not local rotation as it is now. So okay. Now it's basically opposite of where we need it to be. But this is looking good. Well, kind of. So what's wrong with this now? First off, I don't think we need this. I don't care about that. Oh, wait. Oh, no. That's not it. I don't know. I'm gonna do something stupid here, just make that negative compared to where it is. Okay. Okay. Oh. Kinda. This is a lot closer. Well, look at that. Once I go into the positive, though, the shoulder rotation doesn't want to follow. It's a lot closer. Oh, whoops. I didn't click on here, and I missed a bunch of comments. Another remark there about round off errors accumulating for acute triangles. Oh, sorry, Croden. I wasn't paying attention. How soon until it could floss? That's a ways away. Although, Dennis, I have zero idea if you're still watching. I did make this for Hamish. So... enjoy that. Sorry, I was just like mousing over like this. Ah, yeah. We'll have seen that dab. It's fire. Well, thank you. God, this is complicated. So basically, in cases where the arm delta is positive, it just seems to want to position the shoulder back that way. And I don't know why. origin delta angle. Minus shoulder Z rotation. Hey, how you doing? Shoulder Z rotation should be shoulder Z rot. So hopefully I can find some sort of pattern here. That should be this. So let's print this out. No. Rotation. Is that okay? Yeah. $45. No, it's a pretty accurate match. That's what it is, but it's not what I need to be. Some sort of mismatch here. Again, I want to do print. Huh? That's not right. Negative 78. We should be at about 0 right now. No wonder I'm having problems. Jesus. Oh. Christ. You know what I think it was? I was calculating this off of prior to when I was subtracting this up here. So if I just did, well, this isn't terribly helpful right now. So if I just did shoulder to wrist line dot y, and then dot x here, and then that there. Uh-huh. Okay, delta angle is at about 0 right here on the horizontal, which is what I want. And this is about 45. Okay, so up here, this is now good. Down here, I fucked it. Negative 51. Oh, because I think in this case, the arm rotation is now negative, and I'm trying to subtract it from a negative in this case. So, geez. So yeah, now I do need to do this based off of... If I just added, well, that wouldn't... Oh my... Oh! Look at that! Now how does it... Okay, and then that gets flipped. But we don't really need that for the forearm. It looks like. So... Okay. Sorry. Hey, Alex. And if we play this... Oh. No is the negative case that we needed. Whoops. Well, it's just negative 180 minus plus. And look at that! Fuck it. Look at that. Holy shit. So neat. So I think for cases with this is just where the length is greater than the two pieces of the arm. Therefore, there can't be a cosine of it, or there can't be a valid triangle of it. So therefore, it's just throwing these errors. Fortunately, I already wrote code to just rotate the arm to point at something. Just rotate the arm as a whole. Jesus Christ, look at that. Okay, so it was just a whole mix-up, basically, regarding using world rotation and not local rotation. Jesus. Look at this. Okay, so... Man, I love it that it actually kind of got simplified as I went along. Okay. So last thing I can do for this session. Just going to do something real basic. If shoulder to wrist line dot magnitude is greater than or equal to upper right arm bone dot or upper arm length. There we go. Plus lower arm length And again, local rotation because I'm not falling for that shit again. I think something nicer actually would be there to be like a max hypotenuse length or something like that. So that the furthest the arm will be like kind of bent or like mostly straight but still a little bent. If and then just else. So then in this case, nice. Then in this case, we should ideally oh, interesting, because I don't reset the well, that's also still local position. Or turning dot identity, which I think is the equivalent of 0 rotation. Why global rotation works here but doesn't work here, I don't know. But okay. No. Oh, I see. Because I was still dependent on this, which got changed. And now it's the opposite. Oh, because I have them mixed up. Of course I do. How did I have that many errors in that and it still worked? And now it's off by 90. Oh, boy. Well, not even 90. It's... Z-rot. No, I don't want that. Okay, there we go. Holy shit. Okay, so this is looking good. Bye, everyone. Yeah, I'm actually glad I managed to solve it just as time ended, or time's up kind of came. So you were doing animation work now? Yeah, I mean, yeah, a bit, just because I wanted to. Yeah. Again, sorry for starting with the stream unlisted accidentally. That is completely my fault. You should be able to rewatch it in the playback though, so that's good. God, yeah. No, I'm super happy that I managed to solve this damn thing. Maybe it didn't make for the most engaging stream, but yeah. I think I will get back to the level next week, actually. I just wanted to change things up this week. Yeah. Hope you're all doing well and stay healthy, guys. Thank you so much for tuning in. Bye.